So on your page, you have something that looks roughly like this. Here's one focus, here's another. Yeah. No. And we said that if I connect focus to any point on the ellipse, let's say this is D1 and this is D2. When I add D1 and D2, I always get the same thing. And we'll fill that in a minute as far as what that looks like. Here's the actual definition in words. It's the set of all points whose sum of distances from two fixed points is constant. And if you don't know what the fixed points are going to be called, those are the foci. One focus on the right, one focus on the left. Unless it's rotated and it's a vertical, where the axis that's longer is vertical, then you'll just have the two foci located on the vertical axis. Okay? So what we're going to do is this now. If I actually were to add these two up, okay, we're going to call that 2a. And it's entirely related to the dimensions of the ellipse. Okay? From center all the way across to the vertex, that's 1a. From center to, we call this a covertex, that's b. Well, the vertex is always the one further away, and covertex is the one shorter away. Yeah, so absolutely. And now the last piece, from center to either focus, is C. Okay? So now here's some terminology. The long axis, that's called the major axis. And the length is 2a. The minor axis would be how big?
C.
2b. We also sometimes say semi-major, semi-minor, and that's just A and B. Okay, so all the way across from vertex to vertex, that's the major axis, and it's always double A. From covertex to other covertex down here, that's going to be 2b. And if we're just talking about from center to either one, we just say semi-major or semi-minor. Okay?
If the ellipse was like the other way around, would it still be A and B?
Yes. If the ellipse was the other way around, then it looks something like this. I know that's sideways, but that's exactly what it looked like. These are the two foci, and then that's that's still going to be a vertex up there instead of a covertex. A is always attached to the longer axis. B is always attached to the smaller axis. Yes?
A is the distance from the center to the vertex, right?
Yes, from center to vertex. Yep. Okay, any other questions? Okay, so what are the equations you need to know? D1 plus D2. So this is the sum of focal distances. That's always double the major axis. That's 1. Another equation is that c squared is going to equal a squared minus b squared. And if you don't see that, I can quick...
What? Sees the picture. You don't see the... What? I'm tired.
I don't know how to feel right now. We'll just go with it. If you don't see why this equation is what it is, okay, I can do a quick little explanation. Okay, what are these two little points called? Foci, right? When I connect these two and I add these two distances up, what do I get?
2A.
2A. If this point is exactly up here at the covertex, then what should each one of these little distances be? Equal. So if the whole thing is 2A, then each one should be A. Okay? And now, if I go down from covertex to center, how big is that?
B.
From covertex to center is B. From center to vertex is what?
C.
C. So it's just a Pythagorean theorem. Right triangle, Pythagorean theorem, but it's a little weird because C is a leg now. Does that make sense? So this is where the equation comes from. You just have to remember that it's C squared equals A squared minus B squared. Okay? Yes?
So the base, the whole base isn't C, it's just half.
Right. All these letters is just from center to focus, center to vertex, center to covertex. That's what A, B, and C are. Okay? This is all stuff you've seen at one point or another. We're just kind of reviewing that now. This part you may not have been introduced to. This is eccentricity. And that's defined as C over A. So that's the third equation. And it kind of tells you how much this deviates from a circle. This ratio. Yeah. Okay, the closer C and A are, well, you'll see as we get through what the ratios are going to look like, what the ellipses look like, and how this all ties into a hyperbola. Okay? So, all you need to know right now is this. This picture, these are all the different parts. Here are the three equations you need to know. And lastly, the general forms of an ellipse. General equations. I'll give you two options. X minus h squared over a squared plus y minus k squared over b squared equals 1. Or x minus h squared over b squared plus y minus k squared over a squared equals 1. These are the only two options you have. These are the most convenient forms because this is going to be easy to graph when it's in this form. The h and k, what do you think those are going to be?
Point.
What point? What else have h and k been in everything? Well, for parabola, a vertex. For a circle, it was center. Okay? H and K are going to be the center of the ellipse. Okay? If we have the bigger number here, well, that's what A is, right? This tells us that the major axis is horizontal. Okay, here the bigger number is underneath the y variable. So in this case, we have the major axis as a vertical.
Wait, what do you mean?
A is bigger. Whichever variable it's under, that's the direction of the major axis.
So you're looking at the left side first?
I'm looking at the whole thing. I think an example will make this clearer, okay? All right. So we'll start off with an easy one, and we'll go through all the details that you're going to be asked. Let's say we have 9x squared plus 16y squared equals 144. What do you notice in the general equations? They're both equal to what?
1.
1. This is not equal to 1. How do I make it equal to 1? Divide by
9. 3. 144.
144.
Yeah, I knew it. 1. 9.
So then 9 over 144 reduces to a fraction.
I thought it wouldn't reduce. I thought it was an actual number. No, it's not.
I got you.
Yeah. To bed time. 9 divided by 144. 1 divided by 9 divided by 144 equals 1 over 16. And then math. Just you learn math. And then
What's the next one? Oh, it's going to be 9, right? Y squared over 9 equals 1. Okay. So now we have it in graphing form. So this is pretty easy to graph. Where's the center? 0, 0. What's A? 4. Good. What's B? 3. These are always squared, right? Could I find C?
Yes.
C squared is equal to
A squared minus
A squared minus B squared. So that's 16 minus 9. So C is going to be square root of 7, right? Everybody with me so far? Okay. So let's draw a picture. The center is at 0, 0. And now, this is why this form is so nice. This 16 tells you how far to go in the horizontal or x direction. What was A?
4.
So we're going to go 4 to the right, 4 to the left. And how far up and down am I going to go?
3. So what are the big numbers to be?
Always.
What did you ask about?
The bigger number, is that always going to be A? For an ellipses, yes.
And what is root 7?
Root 7 tells you, and you're going to be asked this, how far, go back to your picture if you forgot what C tells you. Distance from what to what? Center to focus, right?
Wait, what?
So let's write down the coordinates of the foci. From center to focus is how long again?
Root 7.
Root 7, because that's C. So the coordinates would be at root 7 and negative root 7, 0.
Wait, one more time.
Well, if the center's at 0, 0, and we just figured out that the center is root 7 away from
Okay, so that's just like either way. So
either way, so you go root 7 right, root 7 left, and that's it.
the y is the same.
Y is going to be the same, yeah. Okay. What else? Eccentricity.
Wait, how did you get the 0 again?
How'd I get what?
Y minus
Well, it's on the x-axis, right? Eccentricity is C over A. So it's root 7 over 4. Okay.
Bam.
So we find all this for every time we
Yes, you're going to be asked foci. They may even ask you for coordinates of covertex or covertices and vertices, which isn't hard. Where would the vertices be? 4 is, let's say, plus or minus 4, comma 0. Covertices would be plus or minus 3, comma 0. Or, yeah, switched it up. 0, comma, plus or minus 3. Okay, so this is basically how it works. It gets a little bit more complicated when it's not a nice equation that's centered at 0, 0. And we'll go through one of those right here. Are there any questions before we go on to the next one? Okay, so let's try this example. Say we have 9x squared plus 4y squared minus 54x minus 8y plus 49 equals 0. Okay, so if you look at where where we're at currently to where we need to go, here it looks like everything's a perfect square, right? Here it looks like everything's multiplied out. What do we do? What is that called to get it from here to there?
Complete square.
Complete the square.
Cool. Raise your hand. Oh, what's that?
So the only difference now is that with parabolas, you only did it once. Here we have 2 squares to complete on. So we're going to take out a 9 from the x's. And what do we get? X squared. Does everybody see where we're getting plus 9 from? Mm-hmm. Mm-hmm.
You didn't know that? Me either.
And now let's take out what from the y's?
4.
And what's left?
Y squared minus 2y plus 1.
Everybody see where the plus 1 comes in?
Yes. So smart, huh?
And you subtract the 49, so you get 1 on the other side.
So we're going to get a negative 49 on the right.
Then you have to add 10.
But we have to add a whole bunch of stuff on the right.
Add 81.
Add 81
And add 4.
and add 4. Very good. We did throw a 9 on the left and a 1, but this 9 gets distributed with this 9, so that's 81 that we actually added. Does that make sense?
Yep.
And instead of a 1, it's actually a 4, because we're going to multiply that out. So that's really 4 to keep things balanced. So now let's write this out. 9, how does this factor?
X minus 3. Square.
Good. Plus 4, and then what's this one?
Y minus 1.
Good.
Square.
And now we add all that up. Negative 49, 81, and 4. 36. Okay. What's the next step? Divide by 36. Good. So then we have x minus 3 squared. 9 over 36 reduces to 1/4, so just put a 4 in the bottom. 4 over 36 just reduces to 1 over 9. And then here's our equation now.
Alright, guys, it's a vertical, right? A major is vertical.
Yes,
Yeah.
because
That's math. That's right.
John's rule.
John's rule. Yeah.
Tell us, how do you know whether it's horizontal or vertical for major
So,
x?
since the bigger number would usually go first, then it would be horizontal, but since it's the opposite. Oh, because A is always bigger, so A is under the second one. That makes sense.
Yep.
See?
So let's write things down. Center is where?
Center, 3, 1.
What's A?
3, what?
9, 3, 3, 3.
3. B?
2.
C?
Wait, hold on.
If you can't get C right away, just think of the equation. C squared is what? A squared minus B squared. Shortcut is just find the difference. We get 5, right? So root 5.
Yeah.
Elasticity.
Elasticity.
Yeah, it's called.
Eccentricity
There we go.
is C over A, so that's root 5 over 3. Do me a favor, just so you guys, when we get to hyperbolas and stuff like that, type in this ratio so you see what kind of number it is. Root 5 over 3. And then the other one we had was root 7 over 4.
Maybe we should draw this, right?
We will draw it in a sec, yeah. Like, what do you get when you do root 7 over 4 from the 0.745? And then what was this one?
That's
wait, no.
0.745.
This is
The
0.745.
other one's 0.66.
Okay, so they're both decimals.
Yeah.
Okay.
And I can't.
Okay. Just hold that thought until tomorrow. Or until Monday. Alright, so let's graph all this. So the center is at 3, 1. How far do I go in the x direction?
Hold on. 3.
X direction, you go 2.
Yeah, right.
So we're going to be at 1 and at 5, right? And in the y direction, we go 3 up and down from the center. So now we're up at 4 and down at -2. Good. Which one is the longer axis? The vertical or the y-axis, right? So the foci are going to be located somewhere here and somewhere down here on the same vertical axis. That's the only difference between an ellipse that's elongated in the x direction versus a vertical direction. Let's go ahead and find the foci. Okay. From the center, how far up or how far down are the foci?
Root 5 over 3. Root 5.
It's just root 5, right? This tells you the distance from center to focus. So, what are the x-coordinates for both foci? What are the x-coordinates for both foci? 3, and then the y-coordinate's the one that's changing, right? We started at what y value?
1.
We started at 1, and then I went up root 5, and then I went
So 3 minus root 5? Plus or minus?
1 plus or minus root 5. You could write them together like that or separately. It doesn't matter. Okay?
I don't know how you got that.
How I got what?
With his brain.
Both sides threw me off. I don't know how you got the.
What's...
I got the 3, but not the 1 plus 5.
Well, because we started at...
Yeah. Okay.
You see it?
Yeah, because you're adding.
We started at y equals 1,
Yeah.
and we went up root 5 and down root 5 to get to the focus.
We didn't start.
Right. We start at the center. Okay? Questions on that? Okay. Those are really the only two kinds of examples that you need to know how to graph, where it's an easy form or if you have to complete the square. The other end of the spectrum is given some info, finding out the equation. So we'll do those real quick.
Hey, Mr. G.
Hey, John.
Hey, I'm actually, like, today you guys, they told me they put variance on medicine, like, you guys go to them and it's like, since you're white and rich, you sell, oh, where you from?
He doesn't know what you're talking about.
You're playing Barrington, we're playing Barrington today.
Barrington? Really?
What was that?
You didn't
Where's
take his
Barrington?
pills this morning, Mr. Gonzalez. Just ignore him.
I took my pills this morning.
What? What's up that?
Barrington.
Oh. Well, that's what I meant to do. For hitting me in the head. I wonder if the camera caught the ID coming in. Probably not.
I'm sorry, Mr. G. Just did it on purpose.
It's down there.
Jump.
We'll go get it. Okay, let's finish this up. We'll be done early.
I don't need it, don't worry. That's like the 5th one I bought.
Okay then.
So you clearly need it.
Hey, who was in this?
No, I only bought
All right,
You
guys,
buy
come on.
one.
With me.
testing.
Torres. Hey, Torres, how many geometry movies did you end up buying?
Combine and what?
The 6-in-1s? The geometry.
Oh, 6-in-1s? I
Yeah.
think I broke the record. It was like something like 20 or something.
Oh yeah, you did.
I bought one.
You got one like every other week.
No, every other day.
You spent like $20 on those?
Yeah, he did.
At least 20.
Yeah,
Yeah.
there were a lot.
In my backpack, I had all the broken.
Okay, guys. Let's.
You know that art thing?
What?
You know your vote thing?
No. Oh no, my memory password. Yeah, it's I don't care.
I think I made that for you, didn't I?
Yeah, because you asked me like, what do you want it to be? I'm like, I don't care. And that was it.
That's all I had to do is vote of.
Huh? You don't know my.
A Taurus 5.
Yeah, but I always know.
Okay, guys. Here we go.
Alex 014.
So here's a simple example of maybe we're just curious how far something is or what distance we need to find, and we have some information. We don't actually need the entire equation. All we care about is the distance between two foci. So I'll draw a picture so we know what we're looking for.
You already found 2 things. Let me tell you this.
Hold on.
Found what's
Do I know how far the center is
Yes.
to one focus?
No.
yes.
Yes.
What letter is that?
That's wait, C.
C.
9.
So how far would the two focuses or two foci be away from each other?
9.
4 away.
2C, right? So we're looking for 2C.
I think it's C. I'm pretty sure the distance between them is 9. It's 4.
Well, let's figure it out.
Because
The eccentricity is 2 over 9, right?
Equals C over A.
Yeah. So how did you get your answer?
Because it's C over A.
I'm listening.
A is 9.
How do you know A is 9?
Because it's C over A, like I said.
How do you know this isn't 4 over 18 and it got reduced?
Yeah, but you don't know that, so therefore.
That's exactly my point. You don't know. You don't know where this came from.
So I'm right.
Okay, so here's how we confirm. Sometimes it is going to match, guys. Other times it's not. So don't just say, oh, well, this has to be C and this has to be A. It might be the case, but we don't know that for sure. Okay, so let's look at what we have. Sum of focal distances is 18. D1 plus D2 is 18. What else do we know about D1, D2? What does that equal? 2A. So A is, in fact, 9 in this case. Hey, John, you can either trust me or go your route and see what happens on the quiz or test.
No, but I was just saying I got lucky.
You did get lucky. But do you guys see the point that you have to check?
Yeah.
Okay.
4, right?
So if eccentricity is 2 over 9, since eccentricity is C over A, we can say 2 over 9 equals C over A, which is 9. So this does confirm that C is 2. So then our answer is, from center to focus is 2 units, so the whole distance apart would be 4.
Alright, I'm down.
Okay?
So what's 4?
From focus to focus is 4 units away.
So is that the B?
C is 2. From one center, or from center to one focus is 2.
Oh, the C. Oh,
From center to the other focus is also 2, right?
Are you always going to double it?
If it asks the distance between two foci, yes. Okay, last one.
That should be right.
So I was looking at the.
You want to get it? Alright.
Okay, let's say vertices are at 8, 11, and 2, 11. And foci are at 7, 11.
Did you pick that up from this one?
No, just kind of a coincidence.
What,
And
7-Eleven?
4 and 11.
3, 11.
Oh, cool.
And the question is, what is the equation? of the ellipse. Okay? What do we need to know to find the equation of the ellipse?
Slope.
There's no slope here.
Yeah.
Slow.
Sorry.
Yes.
Look at the equation, the big one that we had written down. What info do we need?
We need.
You need the center.
Center. Do we know the center?
No.
Can we find it?
Yeah.
Where is the center located in relation to the vertices? Or
An equal distance.
in other words, it's in the
Middle.
middle.
Midpoint.
Midpoint. Good job.
Thanks.
So midpoint of 811 and 211. What would that be?
511. Yeah. Guys didn't even know
I'm sure they did, John.
Wait, question.
Yep.
that.
Could you find that from the vertices or the foci?
Absolutely. Good question. Either way you look at it, the middle of 8 and 2, that's going to be 5, 7 and 3, also 5. So no matter which pair you look at, the midpoint will be the center. And you get 511. All right. So I got some of this.
Wait, does that say 311?
Yeah.
X minus 5 squared over something plus y minus 11 squared over something equals 1. That's what I know so far. If I know the center is at 511, and I happen to know that the vertices are at 811 and 211,
49 and 9. Weird, but it's true.
question is, how far is the center to the vertex? I heard one person. How far is it from 511 to 811?
3.
Or how about 511 to 211?
3.
Either way you look at it, it's 3 units, right?
Yeah.
Which letter is that? A, B, or C? If it's vertices, right?
D.
So A has to be 3,
Wait, why again?
because these are the vertices, right? A is always distance from center to vertex.
Yeah, I doubled it.
And now the other thing that we know, from center to focus, how far is 511 to 711 or 511 to 311? That's C. That's 2, right? Everybody see that? So what last thing do we need? B. If I use C squared equals A squared minus B squared, I get 4 equals 9 minus B squared. So negative B squared equals negative 5. In other words, B squared is 5. So now all I have to decide is where my A and B go.
A goes first.
Why?
Because it goes
Mine.
this
Because it
No,
comes
B
from
goes
the-
first.
This is bigger, isn't
way.
it?
It goes this way.
Doesn't matter which is bigger.
No, A is.
Because all of them line
Well,
up
isn't
on
it
the
like
line.
the way it sits?
They're all the same one.
Just use the alphabet.
Go back.
Think of the points, guys. What's changing here?
The Y.
The
I
X
like
is
the X, I was looking at that.
the X is changed. So the vertices are on the X. Does that make sense? The foci are along X. So A has to be along X. So this number down here should be what? 9. Very good. And then what's the other number here? One is A squared. The other one has to be B squared. So 5.
Ooh, I was so close.
Okay.
49.
All right. Homework is day 4. I'll see you on Monday. Farewell.
Yay.